let's look at exponential growth and, by the way, decay equations. They all look like P of t equals P sub 0 times B to the kt. So this is your population, or amount if you're talking about money, at time t. P with a little 0 is the same thing as P of 0, or initial population. B is your base, and depending on what your base is, other things will change, specifically this constant. And this is time. Okay, that's all the parts of this lovely equation. So we can use different numbers for our base, and then we would have to change our constant. For example, a really common type is if you have percent growth. For example, the bacteria population grows 4.3% every minute, or the population of this particular city grows at an annual rate of 7.5%. So if you've got something that has some word problem that involves a percent of growth, you would write the population at time t equals your initial population times 1 plus r to the t, where r is your percent of growth, or decay. Wow, decay, there we go. So if you're decaying, your population is decaying, that means it's shrinking, which would mean that this number would be negative. Okay, so 1 plus a negative number. All right. If, on the other hand, your problem tells you it's a doubling problem, like the population doubles every 3 years, then you would write it like this. The population at time t is equal to your initial population times 2 to the t over k. 2 because it's doubling, and k is the doubling time. For example, if your population doubles every 5 years, this number would be 5. So, for example, in 5 years, we'll plug in a 5 for our t. 5 over 5 is 1, and you would have 2 to the 1, which is 2. So you would have twice your initial population. So however much time it takes to double, that's the number that goes underneath your time. And similarly, tripling time, you would put a 3 here. I'm going to write it out explicitly, even though it's the same kind of thing, half-life. So when we're talking about exponential decay, a lot of times they love to talk about half-life. So there, your population at time t, and it's exactly the same kind of thing, your initial population times 1/2 to the t over k. And 1/2 because we're talking about half-life, how much time it takes to, we're talking about cutting our population in half. And k, well, we say doubling time, but half-life, let's see, this is the half-life. And what half-life means is amount of time for population to have shrink by 50%. Same kind of thing, all right? I've never seen a third life problem, but they could easily do that, and then you'd just stick a 3 under there instead of a 2. You'll also see, sometimes you'll see, and I can't think of any circumstance where I've used this, but you'll see You'll see some of them that are base E. They'll say that the population grows exponentially, and they'll give you a formula for the population with an E as your base. And I wouldn't really use this one given a word problem, but if you have this, you can transform it to one of these others to get your doubling time or half-life time or percent annual growth. So what I'd like to look at next is transforming between the different forms of these in order to look at how they're related.